Assalamualaikum warahmatullahi wabarakatuh. Today we will gonna learn about AC circuit theorems. Basically, these theorems are the theorems that can be used to solve a circuit. The main idea behind these theorems are to simplify a circuit and also to find out the unknown variable value such as current and voltage. These theorems use basic laws such as Ohm's law, Kirchhoff current law, and Kirchhoff voltage law. And most of these theorems also use Cramer's rule to solve the simultaneous equations obtained from the circuit. In this PBL, we are required to design a circuit that satisfies these following requirements. Therefore, we had come out with this circuit. From this circuit, the theorems that we choose to calculate the value of current and voltage across the resistor R4 are nodal analysis, mesh analysis, and lastly, Norton's theorems.
Hello, my name is Mohammed Isfahan. Today I want to show you how to solve this circuit by using nodal analysis. We have to find current and voltage at R4. So firstly, we calculate XL, XC and standardize all the supply. For node 1, V1 at here minus 20 angle 35 degree over 5 plus V1 over 9J plus V1 minus V2 over 3 equals to 0. Then we arrange the equation. That is our equation 1 for node 2, V2 minus V1 over 3, which is here, minus 6 angle 0 degree for this line, plus V2 over 4 minus 6 angle negative 90, which is at this line. Then we arrange the equation. So this is our equation 2. Next, we solve both equations by using Cramer's rule. Find determinant 0.21 angles negative 17.94. Then find determinant V1 by substitute the first column with the answer. Then find V2. We substitute the second column with the answer. Next, find the V1 and V2. Determinant V1 over determinant and determinant V2 over determinant for V2. Then we can directly calculate our IR4, which is V1 minus V2 over 3. Then we can use the current at IR4 to calculate VR4 by using Ohm's law. Current times with the resistor at R4, which is 3. So there we have, this is our I at R4, and this is our V at R4. Okay, thank you.
Hello and welcome to this video on mesh analysis. So let's take a look for this particular circuit. So for this circuit we need to find the VO across the resistor 4. So now we have 4 loops of circuit and 3 different sources and 2 different signal, which is cosine and sine signal. So we need to change the sine form into the cosine form first, and then you notice that the omega is the same value, so we can find the XL value and the XC value. So list down the details for V1, I1 and I2. Moving on to next step, we assign the mesh current direction according to the clockwise, applying the KVL around each mesh. For loop 1, we have our equation for loop 1, and loop 3, we have equation first for the loop 3, and then the equation for the super mesh for the second equation and the third equation. Substitute the equation 3 into equation 2 and rearrange the equation to get the final answer. For the final answer, we convert it into the matrix form by applying the Cramer's rule. Find the determinant from the original matrix and determinant for I4. To find the I0, which is equal to determinant I4 over with determinant, we get the value for current I0. So now we have the value for I0. By applying Ohm's law, VO is equal to I0 multiplied with resistor at R4. So we have the final answer for VO is 11.6862 with angle of 101.2757 degree voltage. Thank you for watching this video.
Hello, my name is Amiratul, and now I will show you how to solve the AC circuit that we had designed by using Norton's theorem. So first, calculate the value of XL and also XC. Then we had to remove all the voltage and current sources and also turn R4 into open circuit. Next, calculate the value of total impedance. After that, calculate the current from each loop by using mesh analysis, where we could get the current from loop 1, super mesh, which is loop 2 and loop 3, and also from loop 4. Then, substitute equation 3 and 4 into equation 2 and use Cramer rules to find the determinant. From this determinant, we could get the value of current Norton current. Lastly, draw the equivalent circuits of Norton and use current divider rule to find the current and voltage across resistor R4. That's all from me. Thank you.
Hello. Now we will go to the multisim simulations. So now we have our circuit. We already construct the circuit according to the question, where we have a voltage source, 2 current source within 4 loops of circuit. Within the multisim simulation, we can find the single frequency AC analysis. By using it, we can find the voltage value at the resistor 4 and the current value at the resistor 4. By doing that, we can compare between the simulation and all the theorem analysis that we have done. So we have the multisim simulation value for voltage resistor 4 and the current resistor 4. We can compare that the multisim simulation value is exactly the same with the nodal analysis, mesh analysis, and the Norton theorem. So here we can conclude that we can find the voltage or current value for any circuit in the multisim simulation. Thank you.